Okay, hello everyone, and we are now going to go through the examples that are for exercise 11E, which is 11.5 on page 303. Okay, and we have integration by substitution. Now I've already shown you this in the previous video, okay, but we just have a few more examples to go through. Okay, because remember the reverse chain rule, I actually just use integration by substitution for that, and I think it's the safest option. Okay, so let's have a look. The difference here is that they actually give you the substitutions for you to use, okay? So the question is, you've got to integrate this function, okay? And they give you a choice of substitutions. So they give you one substitution in part A and then another in part B, and they want you to figure out which one is the best substitution, okay? You can use both of them, it will give you the same answer, but one is slightly easier than the other. So if our u is 2x plus 5, and this is given to us, and sometimes it is in your exam questions, and if they do give you a substitution, then you must use that one. So du by dx will be 2. That means dx is going to be du over 2. Put that substitution in there, and this is what we will have. Okay, now the problem here is that I have now got an x and a root u, and I've got du there and 2 there, and I've got nothing cancelling out this x, okay? So what I can do is I can now find what x is by using this substitution, and the reason why we're doing it is because they've given us the substitution. Okay, so I am now going to find what x is in terms of u, and it's this. I'm going to sub this in. Okay, and what I'll do is I'll take the other two out. Now I'll take this one out, and I am left with u 3 over 2 minus 5u to the power of a half du. Okay, and this is something that you can integrate really easily. Okay, and the reason why we've done all of this long process is that we couldn't expand this bracket, okay, and you don't know any other rule to integrate this, so you do need to use some other way, and that way is this integration by substitution. So you will have okay, add the 1, divide by the new power, minus 5u, add the 1, divide by the new power, okay, plus c. So finally you are going to have a quarter, 2/5 u to the power of 5 over 2 minus 10/3 u to the power 3 over 2 plus c, and then my final answer I just have to put my u back, so that will give me 2/5 2x plus 5 power 5 over 2 minus 10 over 3 2x plus 5 3 over 2 plus c. Okay, and that is your final answer. Okay, part B says, can you find, basically we've got the same question, but now we have a different substitution to use. Okay, so the first thing I'm going to do is I am going to find du by dx. Okay, so if I did that, I would get 2u du by dx equals 2. Okay, so basically what I've done is I have differentiated the left hand side, I got 2u, and I need to write du by dx, okay, because I am differentiating with respect to x and there is no x here, so I've got to put du by dx there, and I've got to then differentiate the right hand side, and I'll get 2. Find out what dx is. So dx is going to be equal to u du, okay. Now there's, I don't have 2x plus 5 anywhere there, but I do have root 2x plus 5, so I'm going to take a square root on both sides, and I'll get u equals root 2x plus 5, okay. Sub our substitution in, okay, and this is what I'm going to be left with. And now the problem is again that I've got an x here and I don't want that x, okay, so I'm gonna have to rejig this around a little bit, rearrange it. So u squared minus 5 equals 2x, and x is equal to u squared minus 5 over 2. I'm gonna end up with the same thing that I did before. So u squared multiplied by u squared minus 5, bring the 2 out, du, expand out the bracket, and I'll have u4 minus 5u squared du, okay. And as you can see now, look, actually this looks a little bit different to what you had before. This is what you had before. You had these fractional powers, and now you've actually got powers as whole numbers, okay. So that's one advantage of using this substitution rather than the other one. So you're going to have half u5 over 5 minus 5 u3 over 3 plus c, and then put back your substitution. So you are going to have 2x plus 5 power 5 over 2 over 5 minus 5 over 3, 2x plus 5, 3 over 2 plus c. Okay, and as you can see, you've come out with the same answer. Okay, the only difference is we've got a quarter out here and we've got a half out here. It actually, if I had gone one more step, I would have got the same answer. Okay, because this 2 cancels the 4, and the common factor 2 cancels out the 4 and the 10 here. All right, so it's the same answer. Okay, so in this example again we've been given the substitution, so always write the substitution and then differentiate it, and then work out what dx is. Okay, that should always be your first step. Now sub this back in there and then see what happens. So we'll have cos x sine x u cubed du over cos x. Okay, so this gets cancelled by this, but now I'm still left with a term in x. Okay, so I'm going to have to plug in a term in u, and I'm going to have to rearrange my substitution. So sine x equals u minus 1, plug that in there, u cubed times u minus 1 du, and when you expand that bracket, you are going to be left with a couple of terms that you can easily integrate. So that's going to give you u5 over 5 minus u4 over 4 plus c, and then put our u back in. So you'll have sine x plus 1 power 5 over 5 minus sine x plus 1 to the power 4 over 4 plus c, and that is it. And you can leave it like that, don't have to simplify it, okay, unless the question specifies, which in this case it doesn't. Okay, for this one, this is a proving question, okay, so and it doesn't give you a substitution suggestion, so you've got to think about the substitution that you're going to use yourself. So we have to think about, well, what am I going to have my x as? Something that will then square root and then also cancel with something there. Okay, so this integration is actually given in your formula book anyway, but the substitution that you need to start with is you need to let x is equal to sine theta. Okay, and you'll see what happens here now. So put our substitution in there, you'll get 1 minus sine squared theta dx. This will then give us 1 over cos squared theta, okay, because I'm using that identity. And then this comes down to 1 over cos theta dx, okay. Now I've got theta here and I've got x here, so I've got to work out what dx by d theta is here. So dx by d theta is cos theta, okay, so now you can see what's going to happen. Alright, so this was a good substitution for us to choose. Next, dx is equal to cos theta d theta. Put that in there. We'll have 1 over cos theta, cos theta d theta. And then the cos theta gets cancelled by this cos theta, and I'm only left with 1 d theta. And actually that is just theta plus c. Now the problem is that I haven't come down to what I was trying to prove, okay? So I've now got to go back to my substitution, okay? One, I haven't reached what I wanted to reach, and secondly, my answer is in theta, and I want my answer to be with x as a variable. So if x is equal to sine theta, then theta must be equal to arc sine x, okay, which is the same as sine inverse x. Alright, these two are exactly the same things. So that's what I'm going to substitute in there, and I'll get arc sine x plus c, okay, and that is the end of that. Okay, now this example is a little bit different because I'm asked to find out the definite integral. Okay, I've got some limits here, so I've got to use substitution, and I've got to remember to work out what the definite answer is going to be if I plug in the limits. So I'm going to start by my substitution. So u should be x plus 1. du by dx is just going to be 1. dx is going to be du. Substitute in there. I'll get x u cubed du. Okay, make that rearrangement. Okay, so then x is equal to u minus 1. Plug it in there. Okay, now I'm going to stop here because these limits that I've put on, okay, they belong to, they are the limits for x function, okay, not for the u function. So I'm going to get rid of them, and I'm going to work out what my new limits should be, okay. So when x is 2, my u is 3, okay, so 3 should go there. And when x is 0, u should be 1, and that should go there, okay. And now I'm going to expand it out. Well, I'm going to expand it, integrate it. So u4 minus u cubed du, and then u5 over 5 minus u4 over 4, and now plug in your limits for u, okay. And what that means, what that does is, actually, I could have put my x's back here, and then basically I could have integrated, then switched with the x's and kept the limits as they were. But I think this is a little bit faster, okay? In exam, time is of the essence, so you know, you're better off finding out quicker ways of doing these things. And now I'm going to put in my limits, so I'll get 3 to the power 5 over 5 minus 3 to the power 4 over 4 minus 1/5 minus 1/4, and that gives you, if you that actually comes down to 28.4. Okay, so I'm going to leave you to work this out on your calculators. Alright.